हेलो सर, आप लाइव कैसे हैं?
Okay. Hello everyone, and welcome to the third live interaction session of the NPTEL course Network Security. Uh, so, if you have any questions, you can please type them in the chat window. So while we wait for the questions, we'll do some examples. Yeah. So I'll share my screen. So the first example we do is comparing a message, comparing a digital signature with a message authentication code. So the problem is that there is a sender, Alice, who has a message and she's ready to send it to anyone who wants the message. For example, it might be some research paper or technical report and so on. Now, thousands of people on the internet, they want to obtain this message of Alice, but there is, the message is not confidential, but the recipients need to be sure of the integrity of the message. They want to ensure that the message indeed came from the true sender Alice and it was not modified during transit. So the question is, in this context, should we use a message authentication code or a digital signature to ensure the integrity of the message? So recall that we discussed two different techniques, MAC, message authentication code or MAC, and digital signature. So both can be used to achieve message integrity. But in this context, is one of them better than the other? So it's easy to see that a digital signature based integrity scheme in this context is better than a MAC based scheme because when Alice uses a digital signature, she can for the message M that she wants to send, she can calculate the digital signature, which is K minus of H of M, where H of M is the hash and K minus is the private key of Alice. So this is the message along with the digital signature, and this can be sent to all receivers. Each receiver can apply the public key of Alice to this and check that the result is equal to the hash of the first part of the message, which is M. So this way they can verify the integrity of the message. So this digital signature based scheme is better than the alternative, which is a MAC based scheme, because if Alice were to use a MAC based scheme, then she would need to separately connect with every receiver and agree upon an authentication key with each receiver. And using that authentication key would need to separately send the message to each receiver. So this would be a very large overhead since the number of recipients is assumed to be large. So in this case, clearly a digital signature is better because just one message along with a digital signature needs to be sent, whereas in the MAC case, Alice needs to separately communicate with each receiver and send the message to each receiver separately. Okay, so this concludes our example, and we'll return to the screen to check whether there are any questions. Yeah, there aren't any questions so far. So if you have any questions, please type them. In the meantime, we'll move on to the other example. This second example is in the context of SSL or TLS. Consider two parties, Alice and Bob, who are communicating using SSL. Suppose Alice sends a stream of many SSL record blocks, and two of the SSL record blocks sent by Alice, they arrive out of order at Bob because they follow different routes through the network from Alice to Bob. So we have seen earlier that this is a common occurrence. In a communication network, packets can be reordered. Yes. Yeah, apologies for the interruption. So in a communication network, packets are often reordered because, for example, different packets may take different paths through the network. So two SSL record blocks arrive out of order at Bob because they follow different routes from Alice to Bob. So the question is it possible for Bob to correctly reorder the blocks? So the answer is yes, because first the challenge here is that recall that SSL record blocks don't have any sequence number in them. So despite this, it's possible for Bob to correctly reorder the blocks. So yes, it's possible because of the fact that these SSL blocks are sent over TCP, and TCP has its own sequence numbers. So Bob can look at the TCP sequence numbers and put the blocks in the correct order. One possibility is that an intruder on the path may modify the TCP sequence numbers, which are for which message integrity mechanisms are not there. So in this case, Bob can still check that there has been a modification because there is a message authentication code for SSL record blocks, and this message authentication code includes the sequence number, although the sequence number is not explicitly included in the SSL record block itself. But the sender and receiver, they keep track of the SSL sequence numbers, and this can be used to check any modifications in the order of the SSL record blocks and the TCP. If the TCP sequence numbers are modified by some intruder, then that can be detected using the message authentication code, which includes the sequence numbers. Okay, so this concludes our second example. Fine. So we are back to the chat, and if you have any questions, then please ask them. Okay, so if there are no questions, then we'll conclude this session. Thank you.
Can we stop, sir?